Google just came out with GameNGen, which is an AI model that replaces the traditional game engine. A real player here is playing this game in real time at 20 FPS, and all of the footage that you see here is generated by AI. Will this be the end of game engines like Unity or Unreal? This paper right here, Diffusion Models Are Real-Time Game Engines, is a paper that Google came out with that dives into all the details about GameNGen. They actually made an AI model that can play the game Doom, and ironically enough, this game Doom can actually be played using a microwave. So it uses the concept of 2.5D graphics, so it actually uses only 2D images, but based on the way the 2D images are displayed, it could play tricks that make it seem like you're actually looking at 3D. Pretty crazy, right? So using AI to develop game engines has been going on for a while. World Models came out with something that looks like this, which is barely even looks like a rendering of an actual game. And then later on, GameNGen came out with something that looks like this, also barely recognizable. And GameNGen came up with this that blew everyone away. Just look at the quality of what this game engine can generate, or actually the AI model can generate. It's pretty good for an AI model. So what is a game engine anyway? So the idea of a game engine is you have a user input, typically by some commands with a mouse or a keyboard, and you have the physics manager that handles how it interacts with the objects, and then you have the main part, which is your graphical rendering, which is what you actually see on the screen, and then the game loop that handles all of the state conditions of where you're at in the game and keeps track of your scores and all that. And there's all the other pieces that handle the memory, but we're not going to go into the details of that. But this is the overview of the game engine. And then Google asked the question, can we actually replace this game engine with an AI model? And this is what they did exactly. So you have a part that has the data collection via agent play. This part has a reinforced learning training part. So if you guys are new to reinforcement learning, let's take a quick look at some of these amazing reinforced learning applications that have been created. So this is a video from 2-minute papers that came out a while ago with agents playing in a reinforcement learning game. And these agents here have to learn to figure out how to escape the room, and pretty crazy things happen in this game. So these agents eventually learn how to use the ramp and actually fly over to attack the agents that are trapped inside the other area. It's pretty crazy. Just look at this. You can see the agents in red is pushing the slider, the ramps over, and then flies over and use laser eyes to kill the opponents. All of this is through reinforcement learning. Pretty crazy, right? Now here's another example of reinforcement learning with these little cube-shaped humanoid robot blocks trying to learn how to walk. And you can see that in the beginning, it barely learns how to even manage to crawl over to one side, from one side to the other. And then after several thousands of iteration, let's see what happens. So after thousands of hours of training, this robot can actually learn how to walk across this maze without any other algorithm, just pure reinforcement learning. So the idea is they use the concept of rewards and penalties to pretty much encourage the robot to do what the user wants it to do. And all of this is done without any of the standard control algorithms that's typically required to make robots move. Pretty amazing, right? So now that we have the reinforcement learning part, there's another part to it, which is the generative model training part. So this part is pretty much all of the part that generates the new images that we don't see. So as we know, generative AI has been growing very fast in the past few years. So there's things like DALL-E, Flux, Stability AI. All of these companies are coming out with generative AI models. Let's take a look at this generative AI example. So you can see that right here, a guy is typing a prompt that says, a yellow cat in Iron Man costume and helmet in Blade Runner scene with blue and green LED lights, flashlights on helmet and costume. Really amazing rendering. Look at this, all AI generated. So as cool as everything seems, it's not without its challenges. So you can see here that we have two rows, the top and bottom. You can see the top has a lot of noise that happens during the rendering, but the bottom is very clear. So what they ended up figuring out was that on the top is actually without noise augmentation, and the bottom is with noise augmentation. So the idea was to actually introduce noise during the training so that it could actually fix some of these problems that they were seeing. So if you zoom in and look at this area here, you can see that there's a huge difference in terms of the quality of the rendering. So how does it actually predict the future outputs based on the previous inputs? So if we look at the past frames, here's 4 shown, you can see that these are the inputs that the model gets in terms of the different frames that it sees. And then the output is actually the prediction. So the prediction is what it expects the next frame to be based on the previous frames. And you can see that this is a prediction and this is the ground truth. You can see the two are pretty much identical. And here's a few more cases. You can see here that this is another case. And the output looks like this, where this is a prediction, and this is a ground truth. You can see that is almost exactly the same. And here's one more example. You can see that here, the output looks like this. Slightly different in the fire part, but it's still very darn close. So they also added some things with the SDV 1.4 autoencoder. So here's what is before fine-tuning, and this is with fine-tuning. You can see that comparing to ground truth, the fine-tune is much better in terms of the head quality, as you can see here. And here's another example. You can see that these are the 3 cases, and if you zoom into the head area, you can see that it's a lot clearer with the fine-tuned case. So overall, you can see that there's a lot of development happening in terms of the AI space, especially in game engine and game development. If you want to learn more AI and machine learning, check out my website at Kevin Wood Robotics and subscribe to learn more.